Hello, we are finally in chapter 7. I hope that everything is going well for you and your studying. This chapter is on atmospheric circulations. And we're going to start off with the one cell model and explain a little bit more in depth than was in the text. These are global circulations. And why do we need global circulations? Well, we need global circulations to maintain a temperate atmosphere throughout the world. Otherwise, the poles and the Arctic areas would never sustain life because of the ice that is there, and the equator would be too warm for many forms of life. So this circulation moves the heat from the equator to the poles and around, so we have a thorough mixing and a more temperate temperature. This observation of these temperature differences and mixing in the globe or on the globe goes back to the explorers who noticed back in Marco Polo's time, 1300s, who noticed that as he traveled east to Asia, he was going through many climates that were very different from Italy, and those climates include vast deserts. And so you see them here. The Arabian Desert was a big one, and then the deserts throughout China, including the Gobi Desert. In addition, there were other observations from sailors during the time, and they were noting that in this same region around the 30-degree latitude line, there were areas in here where there was no wind at all and very warm temperatures. And that area became known to sailors as the Horse Latitudes. You won't forget this one. And the Horse Latitudes were that the explorers were bringing horses with them in hopes of finding a new world. And in doing that, they would get caught in this area where there was no wind around the 30s. And they became known as the Horse Latitudes because they would need to unburden their ships in order to catch whatever wind was in the area, and they would throw the horses overboard. Don't know if that's an urban legend or not, but you'll find it around quite a bit, so you won't forget that too easily. 1735, George Hadley, a British scientist, came up with a model for these observations, particularly the observations about the sailors who were noticing not only the windless areas, but they were also noticing trade winds that were lower in latitude than 30 degrees north. And those trade winds were beautiful sailing winds that were anywhere from around 25 degrees latitude down to about 15 degrees latitude. And so the sailors really gunned for the that trade wind area and tried to avoid the Horse Latitudes. And in explaining this model, Hadley made 3 assumptions which were all untrue, and he knew all of them were untrue, but models sometimes need to make those assumptions in order to make them work. Note to self, if you have to make that many false assumptions, it's probably not a good model. But his model is very well known as the Hadley Cell, and the 3 assumptions are that the Earth is uniformly covered with water, that the sun always shines directly over the equator, and that the Earth does not rotate. All 3 things Hadley knew were incorrect, but he was trying to explain what were known as the trade winds, because they were the winds between 25 and 15 degrees latitude that the sailors gunned for in order to quickly make their way into trading areas. Let me just get my mouse back. Hold on a second. There it is. The model looks like this. It has one closed cell that's huge and that moves up into the atmosphere at the equator, north to the North Pole, and then comes down along the surface again to the equator. The same cell is seen in the southern hemisphere as well. These are known as thermally driven cells because in each case the equator and the heat of the equator is driving the air up into the atmosphere, and then that air is moving toward the colder air in the poles. Remember, equilibrium. And the pressures and the temperature want to go from hot to cool and from high pressure to low pressure. So this one Hadley cell explained the trade winds, because if you think about the surface return flow from the North Pole, you can explain a wind like the sailors were seeing. The winds seemed to go from north to south, and that was sufficient for Hadley. However, the sailors were also telling him that the wind seemed to go from north to south, and it seemed to go to the west. In other words, it was a northeasterly wind, a wind from the northeast to the southwest. And Hadley just ignored that and ignored the Coriolis effect, which had actually been hypothesized by Galileo's students back in the mid-1600s. But it was an Italian theory, so the British were not really going to go with that. But this was the first attempt to look into that sailor's observation. Just get this back. Good. And like I said, the Hadley cell theory did not explain the Horse Latitudes. It only explained the north to south direction of the trade winds. It didn't explain the heat in the deserts that Marco Polo saw, but again, that was an Italian explorer, so it didn't really matter to the British. And it didn't explain the prevailing westerlies that the sailors had noted that were north of that Horse Latitude zone. I want to point that out to you. So the sailors of the time were noticing that there were trade winds that were very helpful for getting them down to Africa and the Canary Islands. And then on the way home, they hit this dead zone right in here. So they tried to, they invented a maneuver where they tried to go across this very rapidly as they could, and then get to what they knew were the prevailing westerlies north of the 30s. So the sailors knew about the trade winds, and they knew about the Horse Latitudes, right in here, no wind at all. And then they knew about the westerlies that were north of the 30s. But Hadley explained some of it, but not all of it. It was his first attempt. Let's look into more at the next video.